Hello there gamers, and welcome back to another epic Maths Inexorable video. That's a lot of adjectives. Okay, so in this video we're taking a look at factorising quadratic equations where a, in this instance, is not equal to 1. What do I mean a isn't equal to 1? I mean when we recall the form of a quadratic equation being y equals ax² plus bx plus c, where a, b and c are numbers. We don't want a to be 1 when a is actually going to be a different number, so maybe 2. It's 2 in this example question that we've just got here that I'll explain in a second, but it could be anything. It could be 10, or it could be a decimal or a fraction, or negative. It could be anything, okay? So a might be a different number other than 1. We haven't seen that yet, and it does change things, okay? So normally, if let's say in this question, x squared rather, actually had a 1 in front of it, so I just covered that up, what would we do? Well, we'd say, let's find two numbers. These two numbers could technically be the same number, but two numbers that times together to make 3 and adds together to make 7. Okay. Now, I don't even know if those exist. I haven't even thought about it. Maybe they do, maybe they don't, doesn't matter. But in this episode, in this instance here, we today are talking about when x squared rather isn't 1, and let's say it's 2. So what do we do? What's the difference? Okay, the difference is, instead of looking for a number that times is to make 3 and adds to make 7, we need a number that times is to make whatever this number is and whatever this number is, a and c, being times together, so 6, and still they're going to add together to make the middle number, 7. So two numbers that times together to make 2 and 3 being times together, and also add to make 7. So they're going to times to make 6 because 6 is 2 times 3, and they're going to add to make 7. That's the rule all the time. If that was a 3, we'd be looking for two numbers that times together to make 9 and add to make 7 because it would be 3 times 3. Okay. So have a think about it. Times to make 6, add to make 7. Okay. Pause the video if you want to think about it, because you do need to just think sometimes. We're looking at the numbers. This is a little bit trivial actually, but we're looking essentially at the numbers. Numbers, I'm going to write numbers, that's probably a bit too small actually for you guys. Numbers are 6 and 1. Because 6 times 1 is 6, and 6 plus 1 is 7. So they satisfy both, which is really, really, really good. That's what we're looking for. Okay, right, what do we do now? This is the bit that trips people up because there's a bit of memory involved in actually working these out. Instead of just chucking these into our brackets, the answer is not going to be like x like plus 6, x plus 1, or something like that. That's wrong. That's not correct. Okay, we don't want to do that. There's another step, so don't get confused. The next step, the step in question, is we need to do this. We need to rewrite this question, but instead of the middle number, the one with the x's in front of it, we need to write that as the two numbers that we've got being added up. So we're going to write that is obviously equal to 2x squared plus 6x plus x plus 3. Well, 6x plus x is 7x, so these are equal to each other. Makes sense, right? Now, why have we done that? Because this lets us factorise really nicely. The reason I've put the 6 first and the 1 later, you will see in a second. So, here's what we do. We're going to look at these two, the first two terms. We're going to factorise just these two terms. So let's factorise 2x squared plus 6x. So what can we take out? Well, I reckon we can take out a 2x because there is a 2x in both of these. Okay, so I'm going to write 2x. Now, what does 2x times by to make 2x squared? Well, it times by x, doesn't it? Because 2x times x is 2x squared. What does 2x times by to make 6x? Well, that makes 3, doesn't it? Because 2x times 3 is 6x. So we've factorised 2x² plus 6x. Now, over here, I'm going to write plus. Now, we're going to just look at this. Okay, this is where it gets a bit weird. I'm going to write the same bracket again. So I'm going to write x plus 3. Whatever you've got in the bracket, just write it again. Now what you need to do is find out in x plus 3, how many lots of x plus 3 do we have? Well, we've just got one lot of x plus 3, haven't we? Because that's x plus 3 and that's x plus 3, so there's just one lot of it. And now we've got this expression, and now we're going to factorize this. So we're going to go, well, let's write x plus 3 first. There is an x plus 3 in both of these terms that are being added. So I'm going to write x plus 3. Now, what is x plus 3 being times by? X plus 3 is being times by 2x and 1. So this is equal to this. Don't believe me? Let's very quickly expand. Let's use FOIL. First, 2x times x, 2x squared. Outside, x times 1 plus x. Inside, 3 times 2x, that's 6x. Last, 3 times 1, that's 3. Simplify, you get 2x squared plus 7x plus 3, which is the same as that. Okay, so I understand I've just delivered a lot of information very quickly, and this is actually fairly difficult to remember, so we're going to do a couple of other practice questions. We might even do 2 videos on this, because this is quite important. So let's try another one. Okay, we've got another example right here. We're looking at 4x squared minus 16x plus 15. Again, note that there is a 4 in front of this x squared. If there was just a 1 in front of this x squared, we'd be all good, but there isn't. There's a 4, which is a little bit annoying, but it's fine. Okay, so what do? We do the same thing as last time. We're going to now look for 2 numbers that times to make 4 times 15. 4 times 15 is 60. So we're looking for 2 numbers that times to make 60. And the middle number here is minus, see the minus sign, minus 16. So we need to add to make minus 16, okay? So just by looking at this, if we've got 2 numbers that are timesing together to make 60, that means they're either both positive or they're both negative. But if they're adding to make minus 16, well, minus 16 is a negative number, which means both numbers must be negative, because otherwise this wouldn't make any sense. So just something to bear in mind when we're thinking about what these numbers are, they're both going to be negative. Okay, so what's the number? What numbers times to make 60 and add to make 16? I urge you to pause the video and think about it, but if you'd like to just continue, I'll tell you what they are. The answers to this question are minus 10 and minus 6. The reason for that is minus 10 plus minus 6 is minus 16. Minus 10 times minus 6 is positive 60, because 2 negatives make a positive. So they work. So the numbers are minus 10 and, that looks like an 8, that's an and sign, minus 6. Okay, same procedure as last time. We're going to rewrite this, 4x squared, and we're going to break up the minus 16x into a minus 10x and a minus 6x. Okay, so the way that you decide which way around you're going to write this is just by looking at what each one would be next to. I reckon we should go with the minus 6 first, then the minus 10, because I'm seeing a pattern here, and this is just from practice. But let's see what happens if we go with minus 6 first, and go minus 6x, minus 10x, and then just adding 15 on again like normal. We've got this. This is obviously the same as this, because minus 6x minus 10x is minus 16x. So we haven't changed it, so we're all good. Okay, now let's factorize these two. Well, what can we take out? Well, we can take out an x, I know that for sure, because there's an x in both of these. But we can also take out a 2, can't we? Because both of these numbers are even, so they must be multiples of 2. So let's go for it. Let's take out a 2x. Okay, now what's coming out? 2x times what is equal to 4x squared? Well, nothing other than 2x, because 2x times 2x is 4x squared. Perfect. Okay, and then 2x times what is equal to minus 6x? Well, that's nothing other than minus 3, isn't it? Because 2x times minus 3 is minus 6x. Okay, then we're going to add, and we're going to put the same bracket, 2x minus 3, and we're going to see how many multiples of 2x minus 3 are in minus 10x plus 15. Okay, right, let's have a look. So essentially, what needs to go here for this to equal this? Okay, well, I'm noticing that 10 is 5 times bigger than 2, but this isn't a 10, this is a minus 10. So this must be minus 5 times smaller, I guess, than this. So we need to times it by minus 5 to make it the same. Because minus 5 times 2x is minus 10x, and minus 5 times minus 3 is positive 15. So it works. Perfect. Now, plus minus 5, obviously, that's just minus 5, isn't it? So I'll actually just sort of link this up a bit. Minus 5. Okay. So now, both factors have, or both terms, have a common factor again, don't they? That common factor is 2x minus 3. So let's now factorize this whole thing. 2x minus 3. Okay, how many multiples of 2x minus 3 do we have in this term? Well, we have 2x times as many 2x minus 3s. So I'm going to open another bracket. I'm going to put 2x there. There's 2x lots. And then we've got minus 5 lots of 2x minus 3. So we're going to go with a minus 5 there. And once again, we factorised it. Fantastic. Don't believe me? Let's expand. 2x times 2x, because we're using FOIL, that's going to be 4x squared. Outside, 2x times minus 5. What's that? That's going to be nothing other than minus 10x. Minus 3 times 2x. That's going to be nothing other than 6x. And finally, minus 3 times minus 5 is positive 15. Now, if we simplify, 4x squared minus 16x plus 15. And we're back to where we started. So we don't actually need this. This is just sort of checking that it works, which is the beauty in these questions. You can check whether you've got them right or not by expanding them out, which is normally easier. Boom, that is the factorized version of this. Okay. So before I end the video, it should be noted that if you have a question that is obviously divisible by something and it's equal to 0, you can just divide it up by whatever you need. So let me explain. If this was equal to 0, we could also say that this is equal to 0. The reason is because this and this are equal to each other, so if that's equal to 0, then that must be equal to 0 too. Then we can do our normal method. We can say 2x minus 3 is equal to 0, and 2x minus 5 is equal to 0, because these two are timesing together, remember, which means one of them or both of them have to be 0. So we can say this is 0, this is 0. We can then, if I go over to the top one again, 2x minus 3 is 0, which means 2x is equal to 3, because I'm going to add 3 to both sides. Down here, 2x minus 5 is 0, which means 2x is equal to 5. One last step. If 2x is 3, then x must be half of 3, which is 3 over 2 or 1.5. And over here, x is equal to half of 5, because 2 lots of x is 5, which is 5 over 2, which is 2.5. So our answers to this question are x is 1.5 and x is 2.5, okay? Now, this is what I'm getting at. Let's go over here. I'll put this down actually, this crazy thing. If you get a question that looks like this, 4x² minus 8x plus 4 equals 0, solve that, you do not need to use this method, because if that's equal to 0, there is nothing wrong with you just dividing everything by what you need to. So in this one, let's say we can divide everything by 4, because all of those are multiples of 4. If you divide 0 by 4, it's still equal to 0, so you can still keep that as 0. And that right there does not need this method. That right there, you can do that by yourself. And we actually know, because we did this exact question in the last video, that this actually ends up as x minus 1 times x minus 1, doesn't it? And you can try that for yourself. That means that x is equal to 1. So that's a lot faster, isn't it, than like this whole thing. So spot when you have this, because you don't need to use that whole method, when you have a case where you can obviously divide by things, but remember it has to be equal to 0 for you to be able to do that. If there's no equal sign, you can't do that. If it just says factorize this, you just have to do this long method. If it's equal to 0 and you're trying to find solutions for x, is good. Okay guys, so yeah, this is definitely something that I would urge you to try practice questions on. So you're looking for questions in which a in y equals ax² plus bx plus c is not equal to 1. Practice this method. There are other methods to do it, this is the method that I find to be the easiest, even though it's a bit tricky. But absolutely have a go yourself and practice. Do a lot of these, and I promise you, it looks pretty daunting. You'll find it pretty easy in no time. Anyways, guys, thank you for watching, and I'll see you in the next one.